Hi, welcome back. So today we'll look into the second chapter of P2 and P3 on logarithmic and exponential functions. So in this particular video, we will focus just on logarithmic functions. So first of all, let's look at the definition of logarithm. So given that y equals to a to the power of x, so the definition of logarithm is that x will be equals to log base a y. So then from these particular definitions, we have several identities that we can use. So first of all, we know that a to the power of 1 is equals to a. So this gives us the identity that log base a is equals to 1. We also know that a to the power of 0 is equals to 1. So this means that log base a 1 will be equals to 0. Third one, log base a to the power of x equals to x. So what you can see here is that basically a to the power of x is y. So this means that the whole equation is just log base a y, and this is of course based on our definition, equals to x. The fourth identity is that a to the power of log base a, perhaps I should write here, x equals to x. So you can see from um, the definition above that let's start with y equals to a to the power of x, and x is also log base a y. So this is log base a y. So from here you can see that as long as you switch back this to y, you switch it back to x, you get back the equation, which is x equals to a log base a x. So that's how you prove all these four identities. Now let's look at some examples. So if let's say you are given log base x to the power of 3, this is obviously using the third identity, and then the fourth identity, this will be 3 log x, and this will be equals to 3. If you are given log base x square root of x power 5, so you turn back to the power form, log base x to the power 5 over 2, so this will be just 5 over 2. So let's look at the third example. Given that f of x is 1 plus log base 2 x minus 3, x has to be greater than 3. By the way, I forgot to mention, so all these definition of logarithm, there is one very specific conditions. Your a has to be greater than 1, but it cannot be equals to 1, and your x has to be greater than 0. So these are the domain for your logarithm. So example 3, given that f of x is 1 plus log base 2x minus 3, x is greater than 3, find the inverse function. So by now you should know that the inverse function of logarithm is exponential. So first you let fx equals to y, then f inverse of y equals to x. So y equals to 1 plus log base 2 x minus 3. So log base 2 x minus 3 will be equals to y minus 1. So using the definition of logarithm, 2 to the power of y minus 1 equals to x minus 3. So x will be equals to 3 plus 2 to the power of y minus 1, or the inverse function will be 3 plus 2x minus 1. So in this case, you can also look at the domain for the inverse function. You'll find that it will be just the space of all real numbers. So let's look at question number 4. So if let's say you are given a logarithm equation, log base 2 log base 3x equals to minus 1, find x. Given, perhaps I should move one more step. Given that log base 2 and then log base 3x equals to minus 1, find x. So you just need to use the definition of logarithm twice. So 2 to the power of minus 1 equals to log base 3x. So 2 to the power of minus 1 will be 1 over 2. Then 3 to the power of 1 over 2 will be equals to x. Or x is square root of 3. So obviously we don't need to do the plus or minus because x has to be greater than 0. Let's look at question 5. Given that log base 4 2 to the power of 3 minus 5x equals to x squared, find x. So first of all, you can just directly apply this using the definition of logarithm. 4 to the power of x squared will be equals to 2 to the power of 3 minus 5x. So the point here is that you want to make it into the same base so that your index can be the same. So in this case, 2 to the power of 2x squared will be equals to 2 power 3 minus 5x. So here 2x squared will be equals to 3 minus 5x, or 2x squared plus 5x minus 3 equals to 0. So you can factorize this one out. So you have 2x squared here, minus 3 here, 5x here, plus or minus 2 here, 3, 1. So you have minus x, 6x. So then over here you have x plus 3, 2x minus 1 equals to 0, or x will be equals to minus 3 or half. So you can check your answer whether or not this is true. First of all, you just need to make sure that it doesn't hit all the values that you are not supposed to have when you define the logarithm. So in this case, because x does not constitute the arguments inside your logarithm function, so both answers should be accepted. So now let's look at multiplication law, division law, and the power law. So for the multiplication law, basically it states that when you have log base a xy, this is log base a x plus log base a y.